Hello, Chemistry 10HH students. This is Mrs. Altman. We are on video number 41, Bonding Part 1. Here are our objectives for today's video. Pause here. A rough sketch of the picture is completely sufficient. So as you may have guessed from the title of the chapter, we're mostly going to be talking about bonding in this chapter. We're mostly going to be talking about covalent bonding, but we'll talk a little bit about ionic bonding as well. Before we can get into the specifics of covalent bonding, we're going to need to first be able to determine if something is covalent or ionic and what that really means. So there's two main types of bonding, covalent and ionic. There is nonpolar covalent, which if you don't have the word before covalent, you can assume it's nonpolar covalent. That's when electrons that are bonded are shared equally. So that is like the image you see. The blue is representing what's called electron density, which is just where the electron may be. Then there's polar covalent, where electrons are shared unevenly. And then there's a separate category of ionic bonding. It's actually not a bond because there's no constructive overlap of atomic orbitals, but it is such a strong intermolecular force that it is often referred to as bonding. The word coulombic just means that it is coming from the fact that there's a difference in charge. Pause here. Just a little review of electronegativity. So you probably already know fluorine is the most electronegative element. As you go across a period, meaning a row, there's an increase in electronegativity and down a group. That's not a hard and fast rule. There's actually tables of electronegativity that you can look up. Noble gases we typically leave out of the mix. You should know that fluorine, oxygen, and nitrogen are the three most electronegative elements, and that generally speaking, carbon and hydrogen are approximately equal in electronegativity for the purposes of nearly any type of chemistry that you would be looking at in your lifetime. Pause here. Right, I'm going to work through it. I'm going to write down my answers, as, my reason for this as well. So the first one, this is covalent because carbon and hydrogen are so close in electronegativity. CCl, this is polar covalent because there's a difference in electronegativity. NaCl, this is ionic. So ionic, I know that because of the fact that sodium is a metal and chlorine is a nonmetal. ICl, this is polar covalent because chlorine is more electronegative than iodine. And then the last one is just covalent. Since it's the same element, they're equal in electronegativity. Pause here. So we're going to be talking about polar bonds in the context of polar molecules. A bond is polar, as we just saw, if there's a significant difference in electronegativity between the two atoms in the bond. But you can actually have a molecule that has polar bonds without it being a polar molecule. So a molecule will be polar if those polar bonds are placed asymmetrically around the central atom. And this whole chapter is about figuring out how we could predict that this would happen. Pause here. Okay, I'm going to write down my answer, but there's more than one correct way to explain this. So even though CO2 has polar bonds, they are placed symmetrically. Around the central carbon atom. So it is overall a nonpolar molecule. Okay, I'm going to end this video now. Thank you so much for watching and have a great night.